The next question is problem 17. A 13-foot ladder is leaning against a wall. If the top of the ladder slips down the wall at a rate of 2 feet per second, how fast will the foot be moving away from the wall when the top is 5 feet above the ground? Here's my solution. So I'm going to draw a right triangle, and the ladder is 13, and I'm going to call that as my hypotenuse. The distance from the wall to the foot of the ladder is x, and then above going vertically is going to be y. So since it says that the ladder is slipping at 2 feet per second, the dy dt is equal to -2, and then y is equal to 5, and then x is going to equal 12. And so you get that by using the Pythagorean theorem. So let me draw the triangle on that one. So this is always 13, and then at the instant when y is equal to 5, using the Pythagorean theorem, x is going to equal 12. Okay, so now I'm using my Pythagorean theorem of x squared plus y squared is equal to z squared. And since the ladder is going to stay constant at 13, I can put in z as 13. So as x squared plus y squared is equal to 13 squared. Take this derivative, so it's 2x dx dt plus 2y dy dt, and 13 squared's derivative is going to be 0. Cancel out the 2's, so x dx dt plus y dy dt is equal to 0. Substitute in x is equal to 12, dx dt is what I do not know, y is equal to 5, and dy dt is a -2 is equal to 0. Multiply this, bring it over to the other side, and divide by 12, and you get dx dt is equal to 5/6 feet per second. Okay, the next problem is problem 25. A conical water tank with vertex down has a radius of 10 feet at the top and is 24 feet high. If water flows into the tank at a rate of 20 cubic feet per minute, how fast is the depth of the water increasing when the water is 16 feet deep? So here's my diagram. The radius of the tank is 10 and the height is 24. And the radius and the height of the water is what is going to change, so I call that as r and h. It's given that dv dt is equal to 20. You want to find dh dt when the height is equal to 16. So I'm going to first of all get a relationship with r and h. So the r over h, I'm using similar triangles here, is going to equal 10 over 25. Reduce 10 over 25, or I'm sorry, 10 over 24. So 10 over 24 reduces to 5 over 12. And then multiply through, and I'm going to solve for r. So 12r is equal to 5h, and r is equal to 5h over 12. Now I go to the volume formula for my cone, and volume is equal to pi over 3, r squared h. And so in place of the r, I'm going to put in 5h over 12 from this. So I square that, and then multiply that by h. Put together all of the constants, so that'll be pi over 3, and then I have a 5 squared and a 12 squared. So that's going to come out to volume is equal to 25 pi over 432 h cubed. Now I'm ready to take the derivative here, so I'm going to continue it down over here. So dv dt is equal to 25 pi over 432, and then h cubed comes out to be 3h squared dh dt. Substitute in, or simplify first. So dv dt is equal to, simplify the 3 and the 432, and it comes out as 25 pi over 144 h squared dh dt. And now I'll substitute in dV dt is given as 20 from above here. And that is equal to 25 pi over 144. And they want to know when the height is 16, what is dH dt? So 16 squared times dH dt. Okay, so work out all of this. 25 pi over 144 times 16 squared comes out to 400 pi over 9. And then divide or multiply by the reciprocal of 9 over 400 pi times 20. And that comes out to dH dt equaling 9 over 20 pi feet per minute.